Everything in the universe is made up of elementary particles, the most fundamental building blocks of nature. Quantum physics states pairs of particles and antiparticles can be created out of empty space, but exactly how this process happens is complex, which makes it difficult to model using classical computers. Now scientists have modeled the way particles are spontaneously created using a quantum computer, for the first time. This new method of studying the interaction between particles will lead the way towards a better understanding of the standard model of particle physics, and help us understand how everything in the universe began. The standard model says everything in the universe is made from the most basic building blocks called fundamental particles, that are governed by four forces: gravity, electromagnetic, weak nuclear and strong nuclear. Gauge theories describe the interaction between these elementary particles, such as quarks and gluons, and they are the basis for our understanding of fundamental processes. A group of scientists at the University of Innsbruck and the Institute for Quantum Optics and Quantum Information at the Austrian Academy of Science simulated these gauge theories for the first time using a quantum computer. In their paper published in the journal Nature, the researchers explained how they used a quantum computer made of 4 electromagnetically trapped calcium ions. Dynamical processes, for example, the collision of elementary particles or the spontaneous creation of particle-antiparticle pairs, are extremely difficult to investigate, said Dr. Christine Muschig, theoretical physicist at the IQOQI. However, scientists quickly reach a limit when processing numerical calculations on classical computers. For this reason, it has been proposed to simulate these processes by using a programmable quantum system. In recent years, many interesting concepts were proposed, but until now it was impossible to investigate them. We have now developed a new concept that allows us to simulate the spontaneous creation of electron-positron pairs out of the vacuum by using a quantum computer, said Dr. Muschig. Each pair of ions represent a pair of a particle and an antiparticle, said experimental physicist Dr. Esteban Martinez. We use laser pulses to simulate the electromagnetic field in a vacuum. Then we are able to observe how particle pairs are created by quantum fluctuations from the energy of this field. By looking at the ion's fluorescence, we see whether particles and antiparticles were created. We are able to modify the parameters of the quantum system, which allows us to observe and study the dynamic process of pair creation. While hundreds of theoretical physicists work on the highly complex theories of the standard model and experiments are carried out at extremely expensive facilities, such as the Large Hadron Collider at CERN, quantum simulations may be carried out by small groups in tabletop experiments. These two approaches complement one another perfectly, said theoretical physicist Professor Peter Saller. We cannot replace the experiments that are done with particle colliders. However, by developing quantum simulators, we may be able to understand these experiments better one day. Experimental physicist Professor Rainer Blatt added, moreover, we can study new processes by using quantum simulation. For example, in our experiment we also investigated particle entanglement produced during pair creation, which is not possible in a particle collider.